please come in and grab your seats. We want to make sure that all the speakers have time. See, I made it.
If anybody wants to use the
Thank you. Okay, gang, we're starting the next session. If you guys could come in and have a seat, and please stop the side conversations. I need to keep this going. We've got 4 speakers for you, and then we're off to lunch. Just some quick housekeeping here for my speakers. Hands up. Where are all my speakers? I don't see all my speakers. Are they in the room? Joel, can you come on in here? We're getting started. Okay, we're going to do about 20 minutes for each speaker so we can allow for some questions. And we're going to start off with Michael Blazewicz. But just some quick housekeeping. We got 20 minutes, guys. If you see David come up, think of Michelangelo and what David looks like when it's just wrapped up, okay? So you got 2 minutes to wrap it up. If you see Jenny Greenteeth, you're done. She's a swamp witch. She will pull you in, and you'll be part of the infrastructure for the wetland. Okay, let's get going. So some brief bios, and then we'll jump into it. Michael Blazewicz is our first speaker. Michael is a generalist. Sometimes he does good work that has won some awards. He had a cat once. He rode the Grand Canyon twice without flipping, but unlikely a third time since this just jinxed his upcoming trip. He dropped out of nursery school and skipped his graduation ceremony at some Ivy League school in Connecticut. And some people wait for the midlife crisis to find them. He goes out and manifests his every day. So thanks, Michael. And please start your timer. I will do the same.
Grab your microphone. Any last comments? All right. Whoa, that's loud. Okay, y'all. Starting up. Thanks for being here. I have the inglorious job of presenting a document that I am one of the co-authors of, but I am not certainly the manifestor of it or the idea behind it. It's a new document we're pretty excited about, and really this presentation is to gain feedback from y'all, introduce it, tell you what's out there, and hopefully solicit ideas and ways to make it more valuable for all the folks that are out there doing work in our extreme corridors. So we call it, it's a guide for contractors and operators, and we're trying to aim, the big aim is to improve the quality, function, and aesthetic of construction work in our streams, right? I think we all have an environmental ethic here. We all want, if we're doing work in stream corridors, we want to try to, raise the bar, stop making the same mistakes over, and, really try to, get the best work out of all of us, right? So, first of all, our authors for this, myself, but also Katie Yacht up here, Watershed Science and Design, Jeff Sickles with Ingenuity, hiding in the back there a little bit, and Chris Sturm, this is Chris's idea, so he should be up here giving the presentation, but unfortunately you're stuck with me. And so, in keeping with the context of our conference here, we're going to look back, and then we're going to use our kind of looking backwards at what we've been doing with construction and stream corridors in the state of Colorado, and then look forward and try to think about how we can advance the practice. So looking backwards, when I first moved here in 2010, I started doing work with the Measurable Results Program, and that's one of Chris Sturm's stream restoration monitoring programs. And we were looking at, Chris's program is spending money across the state to millions of dollars, all our money to go do this restoration work. And we wanted to figure out, were we doing a good job of it? Was people come in and someone says, we've got a great idea, we can fix your stream, we can, spend the money that needs to get spent, bring in the yellow equipment, do the work, and then leave. And as we've been hearing, that's, as we heard in the plenary yesterday, that's not always something that maybe we don't know that it's actually producing the results that we want it to do. So the Measurable Results Program looks, and it's still going, it's still ongoing, but we're looking at, oftentimes when there's funding through CWCB to do restoration work, there might be a monitoring component of that. And so we want to collect that data and try to understand, is the work that we're doing, what's the benefit of it been? Also looking backwards, I need to acknowledge the 2013 flood. Huge catalyst for us for trying to understand, because we had so many projects all happening at once, okay, well, what's going on with these projects? What are the limitations, and what are the things that we're getting right, and what are we getting wrong? And so out of that came the lessons learned document. If you haven't seen this, y'all, you can find it at coloradoewp.com. And this document is really aimed at, again, trying to help communities plan for, react, evolve, adapt, all looking towards this idea of like a better stream corridor, okay? And so from the lessons learned, we had, amongst the many sections that you'll find in there, from planning and kind of all the permitting and all that fun stuff, we have a section on construction. And of the different, and this is how it's organized, just in case folks aren't familiar with the document, but it's really useful and we want to get it out there to other people, so figured I'd show it here today as well. But amongst the topics the major lessons learned, we made this document by interviewing many of the folks that were in the trenches doing the flood recovery work to try to summarize the big ideas and give that information out to other communities. And so one of the big ideas out of construction, well, was to develop a workbook to detail installation techniques, elements, basically try to create a document that could be worked with for contractors and for designers to kind of bridge the gap. Okay, so we're actually following our own recommendation here with this new construction manual. So looking forward now, after we've looked back and kind of looked at what we've done in the past and what we've gotten right and what we've gotten wrong, looking forward, what are we trying to do here? Well, ideally, we're building projects that increase resiliency, increase processes and function in stream corridors. We need to assume change. We have to get away from the kind of idea of like static channels, right? So we're looking more to accommodating stream processes rather than trying to control streams. We want to make sure that each project is obviously, it's going to be the best project it can be, regardless of which contractor gets chosen to do it. Okay, we can't just have our favorite contractors that do the work, but other contractors aren't going to do as good of work. We want the kind of work to be, if we're spending the money, if all of us are spending our money to do this restoration work, we want it to be great work. So obviously stop making the same mistakes over and over, recognizing that sometimes less can be more. Trying to get away from the idea that we have to do all the things, bring out all the guns to make the work happen, but sometimes a lighter touch in our stream restoration work is important. And then we want to focus on the corridors, not just the channel. We've talked about that at length already. I'm sure you guys, especially if you were here at the last session. And then obviously just in trying to improve the knowledge base and expertise. It's us learning from all of you, and hopefully it's us infusing you all with some new information as well. But really this is a collective, and if you flip through this document, you might see some of your work in there. Hopefully you do. Hopefully it's in the good, and not so much in the bad. I'm sorry about that if it is. But we're all learning. I've done things certainly that I've certainly kind of regret a bit, like my younger self doing some work that I probably wouldn't do again if I had the option today. Okay, so what's the big challenge here, right? How many folks in this room do stream restoration design work? Been involved in coming up with an assessment, doing a plan, creating a design. Maybe you're doing the CAD work yourself or GIS work. Maybe you're, in some way you're kind of creating this plan set. How many folks here actually operate heavy equipment? Jess does. Nice. I get on like a bobcat every once in a while. So we all know what we want, ideally, in our restoration work, right? We have this vision of what we want the project to look like. We develop this plan set, and oftentimes the plan set, we've got nice lines on the map, and then we get out there, and hopefully we're there trying to talk to the contractors, trying to help them understand what the vision that we have in our heads is going to translate, when they're out there moving the machinery around and making things happen. Okay, and how many folks have been in that position and maybe been a little bit frustrated with their ability to communicate what they want to the operator? Sure, right? And it's not that the operators aren't well-meaning, good people as well, but they maybe don't have the experience that we have. Depending on, in the flood recovery work, we had such a, new onset. We had lots of folks that maybe had been building highways and culverts and bridges for a long time, coming into stream channels and doing stream channel work. And looking at plan sets that are well-intentioned and hopefully, detailed and have all the different elements to them, but the translation of what that plan set looks like into what we want our stream corridors to look like, it gets lost a little bit. And so that's kind of really a big reason for developing this construction manual. So the vision is that, we all want, like I said to begin with here, there's an ethic of, environmental stewardship. If we're doing work in stream channels, we hope the heck that we're doing it with an ethic that, of taking care of the land. We know that we should maybe trying to overdo things and avoid some of the, heavy hands that we have at times. And then, obviously trying to naturalize a site and leave the site, better than it was. Can we do stream restoration work where when we walk away, maybe give it a couple years for revegetation to happen, but can we go back to a site and not know that there was restoration work that took place? Wouldn't that be amazing? That would be, how many folks have driven down a corridor and been like, oh, yep, can tell that was a project, and that's, ideally, I'd love that to not know that there's a project that happened there. We want things to blend in. When we leave the site, we want the site to look as natural as possible and to, as soon as the vegetation comes in, have it, over time, blend in and just become part of the rest of the corridor. So what we did, we developed the product. There's the first printing is available on the display table at the Colorado Water Conservation Board's table in the kind of down in the basement there, whatever it's called. And I'll run you through just a few the time I have, kind of what we've got in the contents here, since you all can't look at it with me. But essentially, we're trying to take the general practices that we find across the gamut of stream restoration and categorize them. We have, there's a section on clearing and grubbing, and as Andy said yesterday, decompaction. I don't know how you did that. Decompaction. And then we've got a big section on channel shaping, bed forms, habitat, these kind of these typical elements that we'll find in a lot of restoration projects. We've got a section on grade control and channel training, another section on lateral adjustment control and stream bank stabilization techniques. We've included a topic on floodplain features, including microtopography for mountain streams and plain streams, kind of low gradient. And then revegetation, which is not all of our expertise, but trying to pull in kind of the best information that we could find out there. So we hope that it's organized simply. And sorry, I'm kind of realizing I might be cutting you all off. I'll go cut these people off on this side of the room. So basically we want to, this to be a quick reference when you're in the field. Description and purpose of what the feature is. So you're a contractor, you're told, we need to put habitat boulders in the stream, okay? You maybe you're part of a design team that someone else designed the project, but you're out there doing construction oversight, okay? There's habitat boulders, great. Maybe in your head you know what they are. Does the contractor know what they are? Description and purpose, maybe why they're used. Other names that you might find, for cross-reference. Typical materials that are pulled in for these type of projects, the equipment that you might typically use to place these things, and just in case there's any sort of, well, how do we build that? What equipment do we want to bring into it? Installation fundamentals, the basics, right? Try not to F this up, and hopefully you'll do a good job. Potential enhancements, these are good for maybe going the next level, maybe a discussion that happens on site or kind of in the design room or in the field with the contractor, trying to think about how to raise the standard a little bit. A lot of this stuff is trying to incorporate live cuttings or other materials into some of these structures at the time of construction. And then common failure mechanisms, and this is what we witnessed in doing the measurable results program. It's what we witnessed from doing flood recovery, construction oversight. And so, oops. So it's organized photographs. Pictures are worth 1,000 words, and we try to describe things that we see what we've seen from doing our construction oversight, and make it even simpler by just quick referencing with green checks or a red X. Maybe not our idealized version of what we would like to see. We tried to take include a lot of photographs of the construction process. If you all are building stream projects in the future, please document the process for us. There's a lot of good new techniques. This is not comprehensive by any means. This is a living document. We want the community to continue to contribute to this to make it better. So, but documenting the construction process, it's really nice to be able to go out there with a contractor and talk to them about laying a foundation. What does that kind of look like? What is the first course? Maybe this is a large wood revetment. What might that look like? It's not going to be exactly the same. Obviously, each scale and each site is going to be different. But just in general, rather than just using our words, maybe now we have some photographs and some other things to kind of reference with our contractors. Finished product as well, we feel like that's maybe a great idea because we have these black and white CAD drawings. We have our kind of arm waving, but maybe to kind of show that the contractors, this is kind of like what we're going for at the end of the day. It's really nice, or this is what this is going to look like in a couple years. So we tried to include photographs of that. Again, sorry, not sorry. Some of the work that we've done out there can be better. I can critique myself as well, but there is some photographs of we think that things that maybe aren't our best practice, and we don't want to continue to have those. We'd like to just raise the bar, I guess, is what we're trying to do. So how can you reference this or use this? Hopefully, if you're a design team and you're recommending some of these construction techniques, some of these elements in your stream channels, then maybe you could consult the book to just make sure that you're thinking about the construction process, how things are going to get translated from your design work and your CAD drawings in the field, maybe including some elements that you find in this reference into your design or into your details. And then when you're in the field, obviously having it as and maybe handing it to your contractor too, highlighting some things, circling some things, whatever it is. And again, living document, I think I'm short on time. So this is a pole planting, right? I don't have a lot of photographs of it. The three of us and the four of us couldn't really come up with a good documentation. So please submit more of your ideas and more of your experiences to us. And which brings us to the final slide, thank God, which is to where to find this. So you can find it on the Colorado EWP site under implementation. Or you can find it on Chris's Watershed Restoration Protection Program, where a lot of you might go to find your grants and things like that. And so when you open one of these links, it's going to bring you to this, like a Google Drive essentially, where you will find the PDF as well as a comment sheet. And I think what I'd actually like to is kind of just as I'm preparing this presentation and talking with some of my colleagues, maybe we'll actually also include a submit your new element or something like that. And we can leave the form that we have up there, give us the description of what it is, give us kind of some of the construction basics, give us some of the things that might go wrong with that, submit some photographs to it, and basically help us build this document for our entire community. So, good on time?
You're doing great.
Great.
David, for you.
Questions for me, or for the other peers of mine here that helped me write this document? Yes, sir. Hey, Morgan, sorry. I got a screen in front of you.
I'm curious, I know the state's getting ready to update their design criteria. I'm sure you guys want to incorporate a lot of the structures. Are you taking some of this information and going to feed that design criteria, or how are those two things working together?
Yeah, it's.
Well, whatever kind of.
They will work together.
Okay.
Okay.
Well, 'cause, yeah, I think that
Right, and you know, I mean, there's a bent here to, there's not a lot of maybe some of the urban, you know, and maybe the document needs to be expanded to that, to things that you might find like, you know, sheet pile cutoffs, a lot of grouted structures and things like that are not captured in this document at this point.
Right, but
Yeah.
just make sure that this information's, you know, complementing that information.
Yeah, certainly not.
That's awesome.
Right, yeah, certainly not contradicting it, definitely, yeah.
Don't want to miss it on the design.
Yeah, absolutely. Good point. Thank you. Yes, sir.
Have you guys thought about, or maybe this exists, I mean, any kind of specification templates or at least a depository for specifications? I mean, we're all working with some of the same contractors. I'm seeing, this was a debated question a long time ago.
You want to answer that one?
Maybe Jeff should answer.
So, we,
For whatever reason, the flood recovery probably doesn't win. And how comprehensive,
you're gonna be like you're all gonna wince in pain, but I decided that we would kind of base all of our specs on CDOT specs because there's a lot of information in there that's really useful, and you can just reference it. So what came out of flood recovery was we had developed template specifications, like basically spec revisions that would fit into CDOT specs for all of these different stream restoration treatments. We have a document, it's probably about 90% done. We probably should just put it out there for you guys. Because really it's just meant to be a template. It's meant to be kind of a starting point for you all as you're putting this together. It's not meant to be a final product. That's up to you guys as the designers to wrap those specs up and make sure they meet your needs. But we had 67 different projects that we were able to pull specs from for all these various treatments. So there is something out there, and hopefully we'll be able to make that available to you guys soon.
I think that's great. It's a standardization, working with contractors, where one structure costs $100, the next one's $10,000. What's really the difference? What's included? Awesome, cool, thanks. Yeah, good document. We'll mess it up too.
Comments, questions? Is this dumb? I mean, there's a little bit hubris in trying to come up with this document for sure, and trying to, you know, capture the totality of what's been done that's been out there, and also, you know, try to make some judgment calls on what, you know, seems to be look, you know, better, function better, hopefully, you know, have the resiliency and all the elements that we look for in our stream corridors. So come over to the table. Don't swipe this copy, please. But definitely look through it. It's really hard to kind of like explain the document without having you all have a copy to thumb through. So take a minute and stop by the table. Great.
Thank you, Michael. Great presentation. And just a quick reminder for everybody, he reiterated, I'll reiterate it too. This document's not a you should thing. Nobody told us you should do this. So if you're looking through it and you're saying, boy, they should have done a better job, start thinking about how you can make it better, because that's the request. Please commit to get some of your photos to us so we can make it better. Thank you. Next up, we have Brian Clark. He's going to be talking to us about how much space do rivers need. Because of a shift scheduling thing with Batman, Brian actually fights crime by day and moonlights as a mild-mannered geomorphologist at night. While he normally only uses his powers for good, Brian's abilities allow him to cause avulsions simply by staring down the river. Rivers meander so they can go around Brian. And glacial retreat only occurs because Brian has entered the valley. While his work focuses on process-based restoration, conservation research, and fighting crime, his true passion is playing in rivers with his dog, Bella. And despite what anyone may tell you, Brian's actually 6'6". He's just always standing further away than you think. Same for me, buddy. Same for me.
All right, thank you. So yeah, we're going to be talking about quantifying floodplain connectivity and extent in order to assess stream health and give some guidance for restoration and management decisions. So I'd like to thank my contributing authors. There's a whole group of us, and particularly OTAC, who when we did this work employed about half of us. So it's a large group. Also, the Yampa White Green Roundtable for the Integrated Watershed integrated water management plan, and river network for all their support. So this work was done originally as part of the Yampa IWMP and part of the physical and biological characterization via remote sensing. So it should be noted that most of this work was solely via remote assessment, and that subsequent to us doing this work, there has been and is ongoing kind of field assessments and verification, most notably the fluvial hazard and management studies, as well as the riparian condition scoring as part of the Yampa scorecard project, which are both great, so worth checking out. Okay, so we've seen this a lot, where we have healthy riverscapes, and Riverscape Principle 1, streams need space. And we love this picture of a nice wide valley margin where the stream has the full extent of the riverscape to meander and adjust side by side. There's nice lush riparian vegetation. And it allows dynamic streams, flows can expand, cause some energy dissipation, and we get lots of that biologic interaction within our riverscape. However, in reality, not all valley bottoms, are readily accessible. So here's our ideal situation. And then as we come down, lots of times we have floodplain impairments or inaccessibility in areas where we have, either hydraulic or channel modifications, changes in land use, such as, agriculture, pastures, development, cities, or transportation networks that have been put in that kind of limit our freedom space to a narrower corridor. And we've all seen this as that narrow green strip that weaves through a valley that has what could be a floodplain, but is actually, agriculture land or something else that's out there. And we're using those valley bottoms. So they are critical to people. People aren't gonna be grazing up on the hill slopes or living up on the hill slopes most of the time. So we use those valley bottoms, and that limits the width we have in the valley bottom. Not everywhere can be a stage 0 beaver meadow, as much as we might want it to be. Oh, and we have a double slide. Okay, so our question comes down to, how do we quantify how well connected, a healthy riverscape is, and how do we quantify, the floodplain restoration potential and targets for improvements? And so this is our same slide, which should have been the only one. Okay, we'll go in the right order. So in order to get at that, we're gonna go inside the valley bottom margins, or FHZ boundaries. And so the first thing we do is kind of, think about this, and we identify our maximum potential floodplain extent, and that is, the maximum plausible area that could interact or be influenced by floods or fluvial processes under a natural flow regime. And so this could be the same as a riverscape margin, this could be the same as a fluvial hazard zone boundary, or this could just be identified as kind of the historical or natural floodplain. So the next thing we do is go inside that valley bottom and look at the active floodplain extent. Oop, this isn't working. So, and that's areas where inundation during either frequent, duration and frequency by either low or moderate flows, that's kind of the bank full to annual, maybe the 2-year event, are capable of maintaining that riparian vegetation, those biologic interactions, and keeping a healthy geomorphic and ecological processes. And so once we've identified those two areas, then we can look at the floodplain connectivity ratio. And that is really just, it's a proxy measure for the proportion of the valley bottom that is actively and routinely engaged by those moderate to frequent flows compared to our full floodplain width. And so we're looking at just those moderate flows compared to areas that are activated versus the large and very large flows. And so to just kind of give some examples of how this worked, we've got some selected sites from our Yampa remote assessment work. And so first we're gonna look at something with some moderate resolution data. This is right near the town of Craig as an example, and then we'll move on to these priority areas where we apply some higher resolution data. So, first we start off with our maximum potential floodplain extent, which I think, a lot of us have done using any of these techniques. We pull out the geologic maps, digital topography, relative elevation models, all the way through our whole toolkit. And, here we applied the VBET delineation, and then we came in and modified that based on these other components to narrow it down to a maximum floodplain extent. So the next thing we want to do is identify what is that active floodplain. You know, where is that nice, lush, green riparian corridor that goes through the valley bottom? And so the components we use are floodplain fragmentation by either development or transportation infrastructure. We identify a threshold elevation based on relative elevation above the surface that delineates, you know, right where the upper limit of where that active floodplain is. And then we use comparisons and verification from aerial imagery, geologic mapping, topographic cross-sections, whatever information you have to really narrow that down. Okay, so if we have our maximum potential floodplain extent, the next step is we overlay our transportation network and infrastructure, and then we simply take that and clip it and cut out. We've clipped that, and then we go through and designate areas as either, you know, accessible, marked here as blue because they're actually connected to that river and accessible, or inaccessible because they've been cut off by transportation and infrastructure. So the next step is to identify our active floodplain threshold elevation. And again, it's a relative elevation, you know, above the channel. And so, you know, we'll get more into this later, but, you know, here you can see an example where we've, you know, from other sources have identified kind of an active floodplain, and this is the active floodplain threshold elevation. So it's the height above the surface. And so, you know, this encompasses the floodplain, the active floodplain surface, and any inset fluvial features, as well as the channel. And then from this, we then take our floodplain fragmentation shapefile and just clip it. And so there we've knocked it down so that our active floodplain is now all land below that threshold elevation, right, that is not inaccessible or disconnected by the transportation network. And so once we have our active floodplain, we can get a floodplain connectivity ratio where we just take the active floodplain extent divided by our maximum potential floodplain, and here we have a floodplain connectivity ratio of 52%. So 52% of our valley bottom could be occupied, you know, by that active and healthy riparian corridor. Okay, so if we move to some higher resolution data, in the middle Yampa, we will look at kind of 3 riverscapes right in a row. And so again, I'll kind of breeze over our maximum potential floodplain, but, you know, here in the general setting is we're right by the town of Hayden. You know, we have kind of a wide valley bottom. In this area, we have Pleistocene terraces that are actually perched up on top of the bedrock on our valley margins. And then we do have kind of tributary deposits and alluvial fans that are coming down into our valley bottom. And as you can see here too, we also have, you know, the town of Hayden as well as a transportation network. Here, this is US 40 as well as the Union Pacific Railroad that come and cut through this area. So here we've delineated our maximum potential floodplain in orange. This is just kind of the major roads coming through this area, and there's our main stem. And you can see there's a lot of green. You know, in here you can see fluvial features, you know, maybe a little less, and then here, you know, it's kind of pinned to one side. So to get at our active floodplain threshold elevation, which is now a mouthful while my mouth is dry. So here, to get through this, we kind of take a series of things where we look at, you know, we take a whole bunch of cross-sections to go across this area. We look at all of our aerial imagery. We look at the relative elevation models to try and get the relative elevation to match up with where we're seeing those kind of active fluvial features as well as the riparian vegetation. And it's not just one cross-section. We do numerous cross-sections all the way through to get a better sense of what this looks like. Then one other, oh, there they all are. So one other component we add to this is doing a threshold elevation sensitivity analysis. And so what we do here is starting at a low elevation, we calculate the floodplain connectivity in progressive increments as we move up, and we look at what that floodplain connectivity ratio is. So you can see if we start down at you know, 7 feet, we can, you know, and even if we go lower, we see the slow progression as we go up in elevation, where our floodplain connectivity ratio, and that means our active floodplain, is progressively increasing as we go up. And then we tend to hit this threshold where we see that there's really no change in our floodplain connectivity ratio, even though we're measuring from a higher elevation. And so no change in this means there's little change in our active floodplain. And so here that's indicative of kind of steeper confining boundaries. So that really delineates those boundaries. Then after we see that no change, we then see a really steep rise in our floodplain connectivity. So it gets much larger very quickly. And so this is indicative of kind of large expansion, of the floodplain across our maximum floodplain, our maximum potential floodplain. So we've gone up, and now all of a sudden the floodplain has increased dramatically. And so when we do that, we can either see kind of a progressive expansion again of that floodplain, if it's going up in increments across that maximum potential, or we might see no change, meaning that we've kind of gone out either all the way to the valley bottom or the valley margins, or we've run into some of our transportation networks that have made this inaccessible. So if we look at this from an REM, this is an REM from the active floodplain, the threshold elevation we've identified. So this is all areas below that threshold elevation. And what you can see here is that in this area, we see some higher surfaces around Hayden. We've got some agriculture, pastures mixed in there in this area. Over here again, we have some high pastures, raised areas, and as we come down, if we were to just take that threshold elevation, it would actually span across almost the full width of the valley bottom. So then we take that shapefile there. Oh. I don't know what that is. Well, what we would do is we would clip it, and you'd see a really pretty picture of what those active floodplains are, as well as the maximum potential floodplains for each of those. And the points would be that we can see in this area here, where we have the town, we have more development, transportation networks, and so we've clipped that down a little bit further. In this middle floodplain, it actually is almost bisected by US 40 and the Union Pacific Railroad. So almost immediately, we could, at most maybe get to, 70%, but even with that, we have some raised agriculture, pasture land, some development in there. And so we've cut it down to, 60% of that valley bottom is accessible floodplain. And then as we come down, a little further down into our Riverscape 20, we actually have, the whole floodplain would be accessible, except it's cut off by US 40 and the railroad, which have then been kind of pushed up against the margin of that valley bottom. And so in this area, we actually have a much wider active floodplain, which we do see in the imagery, where we see, really great riparian vegetation, lots of fluvial features, and it is active, at those frequent to moderate flows. Let's hope this one works. All right. So the conclusions and implications of this. Okay, so the floodplain connectivity ratios can be used to quantify both the proportion of the valley bottom that's occupied by a well-connected and healthy floodplain, or inversely, the proportion that's inaccessible floodplain. So here you can see kind of different schematics of showing changes in our freedom space that allow that river to move and adjust back and forth and actually maintain riparian vegetation. And the more space you have, the more healthy valley bottom is accessible. So likewise, we could use this to set targets for floodplain restoration and identify areas for improvement, such as low-hanging fruit, specific impairments. If we want to target specific aspects, we